The first thing I want to do this morning is quickly just touch base on some things I noticed from some of the work that was submitted into MathSpace yesterday. There's a few questions that came up from a few different students, and there was a few questions that people seem to be struggling on and identified as, you know, these were weaker sections from the people who have done the work so far. So I just quickly wanted to come back and touch base that. So one of the more questions that people were struggling on were, which of the following equations are of circles, and choose all appropriate answers. So that idea there that we're asking you to choose all appropriate answers indicates that there's potentially more than one option here. And that's a favorite kind of thing MathSpace does with multiple choice questions as well. So let's quickly scroll through some of these options. So if we look at option A, which was 5x squared plus 2y squared equals 25, that doesn't quite fit our idea of our circle, which is x squared plus y squared equals r squared, or more generally, x minus a all squared plus y minus b all squared equals r squared. Option A doesn't fit one of those two. So not quite sure if it's a circle. So I'm just going to leave option A, and we'll come back and answer option A in a second. If we look at option B straight away in the form of x squared plus y squared equals r squared. It's important to note that the radius doesn't have to be exactly a square number. You can have a radius, you could have, let's undo that, your equation equal something like 21. A radius of 21 is, when you square root it, you're going to be left with a surd. That's okay. So that's that. If we look at option C, if we rearrange option C, so I've just kind of got that down there. Option C, if I add x squared to both sides, you can see that we'll be left with x squared plus y squared equals 5. So option C is definitely a circle as well. Coming to option D, it's very similar to option A, but one thing that option D has that's different to A is that there's common factors. So if I look at that left-hand side there, the 5x squared plus y squared, I can think of that as 5x outside of, I can think of it as 5 outside of x squared plus y squared, which I can simplify that to 125 divided by 5. Well, that's just 25. So option D, when we factorize and divide that common factor from both sides, we are left with a circle as well. So that's a circle. Now that we've done that with D, if we come back and look at A, the problem with A is that you have a 2 and a 5. The 2 and the 5, what they do, there's not a common factor there. We can't get them out. And what that means all of a sudden is our x squared and our y squared are slightly different from each other. Very close to a circle, but what that happens when our x squared and y squared are multiplied by different scalars, we get an oval or an ellipse. And I'll drop that into Desmos in a second. So option A is definitely not a circle because x squared and y squared, they're multiplied by 2 different numbers, whereas D is a circle because they're both multiplied by 5. Option E, look, if we expand those brackets, it's the first term squared plus 2 lots of the middle plus the last term squared equals 25. Because we've got this 2xy in the center, that straight away cancels out the circle part. It's not just x squared plus y squared. We can't use that as a Pythagoras' theorem kind of statement. So that one doesn't work. And finally with F, if we rearrange F to get x squared and y squared on the same side, it'll be y squared minus x squared equals 5. And that's negative. And that's not how Pythagoras theorem works either. So F can't be a circle. So there's only 3 options there. And if we quickly flick over to Desmos, that's option A, which was your oval. And you can see the 5 and the 2, what they do is they manipulate the major and minor axes and stretch it out to make it an oval. So that's what why A is not a circle. If we look at, what one was that? I think that was option E. That graph, it looks like it's 2 parallel lines that we've got happening for ourselves there. And as you zoom out, they just seem to continue along for quite a substantial amount of time. And then finally, option, I think that was the last one, F, that gives us this kind of interesting looking graph as well.